Welcome to my channel Phi Concepts CHM. This is the fourth part of the series of bridge course for TYBSc solid state physics. It consists of 4 modules. This is the fourth module, that is semiconductors. In the last module, that is third module, we had seen about the different bands that are formed, that is the valence band and the conduction band, and we had also seen about the band gap. Then we had seen the classification of solids on the basis of this energy band gap. Solids can be classified into 3 types. One is the insulator, which has a very large band gap. Second is the metal, which does not have a band gap. And third is the semiconductor, which has a small band gap. Semiconductor. The material which has electrical conductivity between that of a conductor and that of an insulator is called as semiconductor. Examples: silicon, germanium, graphite. They form the foundation of modern electronics, including transistors, LEDs, that is light emitting diodes, solar cells, etc. Their forbidden band is small. Germanium has an energy gap of 0.7 eV and silicon has an energy band gap of 1.1 eV respectively. An appreciable number of electrons can be excited across the gap at room temperature. By adding impurities or by thermal excitation, that is by supplying thermal energy, we can increase the electrical conductivity in semiconductors. Types of semiconductors. There are 2 types of semiconductor. One is the intrinsic semiconductor. Second is the extrinsic semiconductor. Intrinsic semiconductor. These are pure semiconductors. Example: silicon, germanium. Both these semiconductors are most frequently used in the manufacturing of transistors, diodes, and other electronic components. The number of electrons in the conduction band is equal to the number of holes in the valence band. Extrinsic semiconductor. They are formed by adding suitable impurities to the intrinsic semiconductor. This process of adding impurities is called as doping. Doping increases the electrical conductivity in the semiconductors. The added impurity can be pentavalent or trivalent. So depending on the type of impurity added, the extrinsic semiconductors are of 2 types. One is N-type, the other is P-type. Extrinsic semiconductor has high electrical conductivity than the intrinsic semiconductor. Hence, they are used for the manufacturing of electronic devices such as diodes, transistors, etc. The number of free electrons and holes in extrinsic semiconductors, they are not equal. Extrinsic semiconductor are of 2 types. One is N-type semiconductor. Second is a P-type semiconductor. N-type semiconductor is formed when you add a pentavalent impurity to the pure semiconductor. And a P-type semiconductor is formed when you add a trivalent impurity to the pure semiconductor. PN junction diode. When an N-type semiconductor is joined with the P-type semiconductor, a PN junction is formed as shown in this figure. The region where the P-type and the N-type semiconductors are joined, that is called as a PN junction. It is also defined as the boundary between P-type and N-type semiconductor. This PN junction forms a most popular semiconductor device known as diode. These are some e-resources that you can refer. This question you can attempt. Thank you for watching this video.